So I had a question on some of the content that we covered up till last Tuesday. So this is the reminder of the sign convention that we covered. So hopefully you will have this memorized soon. The sign convention, it can refer to other quantities too, like radius of curvature. But the quantities that we really care about are these: the object distance, image distance, and the focal length. Because in geometric optics, these are the quantities that you will deal with the most often. The other quantities, like radius of curvature, I mean, it's good stuff to know, but you're not going to see that much either in homework or in exams. So all three of these quantities have a very specific meaning when they have a positive sign and when they have negative sign. Those signs actually carry meaningful information. They mean something, you can't ignore it. So focal length is either the easy or harder one. So when a focal length is positive, that means whatever optic you are dealing with is converging. And when focal length is negative, that means whatever optic you are dealing with is diverging. And you might say, oh, that sounds clear. There's nothing confusing there. The reason I'm saying this could get confusing is because this sign convention, it's meant to apply both to lenses and mirrors. It's one sign convention for both of them. You don't need two separate sign conventions if you describe them carefully. So with the focal length, I want to describe as converging and diverging, not convex and concave, because with the lenses, to get converging, you need something that's convexy. And with the mirrors, you actually need something that's concave to get something that's converging. So that's the part you have to work out yourself. You have to know enough about the mirrors and lenses to have a feeling that when you look at this mirror, you have to know that this is a converging mirror. Right? Okay. So, all right. So that's one. The other one, with the object and image distances, the easiest way to memorize it is the plus is the more natural, normal sign. So with the object, that means you have, this is when you have a real object. So this is the most usual circumstance. It actually takes a fair amount of work to get virtual object. And the characteristic of real object is that it's on the same side, it's on the same side as incoming light. I'm running out of spaces. Same side as incoming light. That seems natural enough. So when you have a real object and you have optics here, the light is coming from this real object, so it's on the same side as the incoming light. The image, I guess what I consider to be the normal or usual or the default image is the real image. I mean, that's why we use the word real. And whenever you say something is virtual, there's a kind of a negative connotation to it, like it's not, real, like virtual reality or virtually true. Virtually true means it's not actually true. So real image is formed on the same side as outgoing rays, because that's what makes an image real, because the light rays actually end up where the image is. If they only appear to be there, but appear to go through it, but they don't actually, then that's not real image. So with the real image, it's on the same side as outgoing rays. And the minus signs are then the less usual case. So this would be when you have virtual object or virtual image. And the way an object could be a virtual object is if the object that you're using for analyzing that optical element is not actually on the same side as the incoming light. It's actually on the opposite side as incoming light. So opposite to incoming. So that means since the incoming rays, they have to go. So incoming rays have to go through some optics before they ever reach where the object is. That means where your object is, the light rays never get there. The virtual images, that's the one that you are more used to seeing. It's once again on the opposite side to outgoing rays. And with this particular way of incoming, outgoing way of describing this one table should work both for lenses and mirrors. And if we want to, sometimes examples help more than these kind of abstract descriptions. And the example I like to start out from is the converging lens that forms a real image. So if you have an example of a converging lens of some focal length f, and you have an object that's a real object that's outside this focal length, so somewhere around here, then the image of this object that's formed by this lens is going to be a real image that forms on the other side. So these rays. So, and this is the, actually let me do this in red. So this is the image. So these are the distances, the object distance and the image distance. And I like this as an example because this is the example where all three quantities are positive. Focal length is positive, object distance is positive, image distance is positive. So if you get any one of these three quantities to be negative, it's because you are changing something qualitatively. Focal length, instead of it being converging, it's diverging. Image, instead of being on this side, you are on the other side. Or an object, instead of being on this side, you are on this side.